So, have you ever stared at a massive data set? Maybe it's a huge list of customer emails or a giant log of user IDs, and you realize it is just absolutely crawling with messy, duplicate data? Yeah, we've all been there. It's a completely universal headache in programming. You end up writing all these extra loops, spinning up temporary lists, and just churning out lines and lines of code for the sole purpose of filtering out the noise. Well, welcome to today's explainer, where we're going to look at a feature built directly in a Python that solves this exact problem instantly. It's incredibly elegant. Today, we are mastering Python sets. Okay, let's quickly map out our journey for today. We're going to cover exactly what sets are, how to create them from scratch, the right ways to add and remove elements, their absolute superpower, which is mathematical operations, a few beginner mistakes to avoid, and finally, how all of this gets used in the real world. All right, let's dive right into section 1. What exactly are Python sets and how do they fix the duplicate data problem? The strict definition here is absolutely key. A set is an unordered collection of unique elements. Now, if you write a lot of Python, you're probably super used to lists or tuples. But the thing about lists and tuples is that they maintain the order of your items. And critically, they let you store the exact same value as many times as you want. Sets? Sets throw both of those rules entirely out the window. They literally do not care about order, and they absolutely reject duplicates. And that leads us to this crucial point. Duplicate items are automatically removed. Think of a set like a bouncer at an incredibly exclusive club. If the number 5 is already inside the club and another 5 walks up trying to get in, the set just turns it away at the door. You don't have to write a custom script or a loop to check if the value already exists. The data structure just handles it for you natively. It's an automatic, built-in cleaning mechanism. Moving right along, let's look at section 2, creating and formatting sets, where we'll actually build the foundation of our code. So, this brings us to a really classic trap, one that catches pretty much everyone at least once. If you want to create a brand new empty set, you have to explicitly use the set function. You might logically think to yourself, hey, sets use curly braces when they have items in them, so I'll just throw down some empty curly braces to make an empty set. But if you do that, you actually summon an empty dictionary instead. Using empty curly braces is just a remarkably easy way to accidentally introduce a totally different data structure into your code. So for sure, always use that set function when you're starting from scratch. Before we start throwing data in there, let's just rapid fire through the core properties of our newly created set. First, they're unordered, meaning they completely forget the sequence you added things in. Second, they're mutable, so we can freely change them after they're created. Third, as we know, absolutely no duplicates. And finally, they can store mixed data types. You can toss an integer, a string, and a Boolean all into the exact same set, and Python won't even bat an eye. Now that we've got our setup and running, let's transition into section 3, adding and removing elements. This is basically the day-to-day maintenance. Okay, so how do we actually modify these things? The life cycle is super straightforward. If you want to add a single item, you just use the add method. Easy enough. If you have a whole chunk of items, like another list, that you want to dump into the set all at once, you use update. But the removal process is where it gets kind of interesting. You could use the standard remove method, sure, but if you try to remove an item that isn't actually in the set, Python panics, there's an angry error, and crashes your program. Instead, you're usually better off using discard. The discard method is totally safe. If the item is in there, boom, it's removed. If it's not, Python just shrugs and keeps running your code without a problem. Oh, and we have to talk about this quirky little method called pop. If you use pop on a normal Python list, it usually just snips off the very last item. But remember our foundational rule? Sets are completely unordered. Because there's literally no last item, using pop on a set removes a completely 100% random element. It is exactly like reaching into a bag blindfolded and just pulling something out. You have zero way to predict what you'll get. It's a really fascinating quirk to keep in your back pocket. All right, heading into section 4 now. Honestly, this is the climax of our explainer. This is where sets graduate from being just a basic storage container to becoming a wildly powerful analytical tool, mathematical set operations. Think back to those Venn diagrams you probably drew in middle school math class. Sets give us 4 main superpowers here. First up is the union, which seamlessly combines all unique elements from 2 sets. It's like merging the 2 circles completely together. Second is the intersection. This one is incredibly useful. It returns only the common elements, meaning just that overlapping sliver right in the middle. Third is the difference, which gives you elements that are present in the first set but not the second, essentially carving out the overlap. And lastly, we have the symmetric difference. That one gives you everything in either set but strictly excludes the overlapping parts in the middle. Imagine trying to write custom loops and if statements to perform all those comparisons. It would be dozens of lines of logic. With sets, it literally takes a single line of code.
But hey, with great power comes a few pitfalls, right? Let's quickly jump into Section 5, Common Beginner Mistakes, just so we can avoid the most obvious traps.
We already covered that whole curly brace dictionary trap earlier, but this is the other major mistake. Because we're all so incredibly used to lists in Python, it becomes pure muscle memory to try and access the first item of a collection by typing mySet0. But let me say it again, sets have zero concept of order. There is no index 0, there's no index 1, no index anything. If you try to do this, your code is going to crash hard. The correct, and really the only way, to access the elements inside a set is to use a loop, and just iterate through them one by one.
So, we know the rules, we know the math. Let's wrap this all up with Section 6, Real-World Applications, and see how this actually gets deployed in the wild.
Those mathematical superpowers we just talked about, that is exactly why sets are so indispensable in professional programming. Whenever the concept of uniqueness is important, sets are the go-to tool. In data analysis and machine learning, you're constantly using them to sanitize massive data sets and strip out duplicate records before you even think about training a model. In database operations, they're used to efficiently manage user permissions. Think about recommendation systems or search algorithms, right? Finding mutual friends on a social network or figuring out common search terms between two users. Under the hood, that is basically just running an intersection math operation on two sets. It is highly efficient and incredibly fast.
By instantly transforming these messy, redundant lists into perfectly clean, distinct collections, Python sets give you a profound level of control over your data architecture. It really goes to show that uniqueness is incredibly powerful. So as you head back to your own projects and pipelines, I'll leave you with this to think about. What duplicate data will you eliminate today? Thanks so much for joining me on this explainer, and keep coding.